Okay, let's see the other example. It's pretty much um, similar to the previous example, except that we've got to find the solution which is related to the following conditions. At x equal to 0, y equal to 1, and at x equal to 0. The first derivative of y equal to 0. That means the general solution that we have C1 and C2, you've got to find the value of C1 and C2. Now, if you look at this differential equation, this is the what order? The second order, right? It's order 2. Order 2, you have to find 2y. And the problem statement already gives you 2y. But the thing is that it is asking us that prove that this y1 and y2 are the solution of this differential equation. Okay, and then like if they are the solution, then we got to prove that they are linearly independent to each other. Then we can write down the general form of that, right? And then we just plug the conditions in there to find the value of C1 and C2. Okay. Now our y1 is equal to exponential of 2x. So we got to do the derivative, the first derivative of y1 and the second derivative of y1. Okay. The first derivative of y1 equal to 2 exponential of 2x, and the second derivative of y1 is equal to 4 exponential of 2x. After you get this, you plug y1 and its derivative into our differential equation. You will get which is equal to 0, right? So that means do the same for y2. y2 is equal to exponential of minus 3x. You do first derivative and second derivative. The first derivative you get minus 3 times exponential of minus 3x. And the second derivative you would get 9 exponential of minus 3x. Again, plug y2 and its differential term back into the differential equation. We will get 9 times exponential of minus 3x plus, actually minus, right? Because plus and minus, you will get minus. Which is equal to 0. So that means exponential of minus 3x is also the solution of this differential equation. Now we are going to prove their linearly independent. We take the Wronskian of y1 and y2 because this is, we have only two functions. When we do the set of Wronskian, we would get 2 by 2 matrix. Okay. Okay. For 2 by 2, it's easy, right? I guess everyone know how to do determination of 2 by 2 matrix, right? We would get what? minus 5 exponential of minus x, which is not equal to 0. That means y1 and y2 are linearly independent. Therefore, yc is equal to c1y1 plus c2y2, which is equal to c1 exponential of 2x plus c2 exponential of minus 3x. But this is not it, because the problem statement itself gives us two initial boundary conditions. So in that case, we got to find C1 and C2 by those boundary conditions. The first boundary condition said that at x equal to 0, y is equal to 1. We just plug it in. This y means yc. Okay? So we would get 1 equal to C1 plus C2. The second boundary condition say that at x equal to 0, the derivative of y is equal to 0. But before we put this boundary condition into our answer, we got to do the derivative of our answer first, right? To do the derivative of yc, we would get yc prime equal to c1 and c2 are constant. So you would get 2c1 and minus 3c2. And then after you do the differentiate of c1, you can plug in the boundary condition. Okay, we will get 0 equal to 2c1 minus c2, or c1 equal to 3 over 2c2. And then I just put c1 back in here. I would get 3 over 2 c2 plus c2 equal to 1. 5 over 2 c2 equal to 1. So c2 equal to 2 over 5, and c1 is equal to 3 over 5. Now, the final answer is yc equal to 3 over 5 times exponential of 2x plus 2 over 5 times exponential of minus 3x. That is the answer. Any questions?